All right. Well, thanks everyone for being here for this session. I'm very excited about the discussion. One of the discussions that we are having more often is not just about DevOps, but how is DevOps evolving? And one of the foremost themes that we found in our research on cloud native DevOps is this idea of how these feedback loops are getting tighter and tighter. And we're starting to see more and more organizations use these micro feedback loops. I was reading a story on martinfowler.com about this and about great developer experiences versus not so great developer experiences. And so that brings us to this question about, what is ML ops for a DevOps team and how does it help improve that feedback loop that you're getting? And maybe Aparna, you can get started and help us kind of get your thoughts on this and perspectives.
Yeah, absolutely. Hey, everyone. So good to be here. I feel like I'm going to start this off a little controversial already, but I think ML ops is not the same as DevOps. Fundamentally, ML ops is a fundamentally different problem than DevOps. It's operationalizing models, which is different than operationalizing software or data pipelines. I think, sure, there's some overlap, but it would be wrong to see them as the same. And just a little bit of background on myself. So previously I was an ML engineer over at Uber. Little ex Uber mafia over here with Kevin on the panel as well. But at Uber, when we had this role of kind of an ML engineer, who was the person who really operationalized those models, put them into production, and they were fundamentally different than the people who actually did DevOps. And my opinion on this is that the person who should do DevOps for models is really, someone who's trained to understand that model, understand how it's built, and more importantly, know what the definition of good is for that model. Is a DevOps person going to know, is this model good or not good? Models are fundamentally, it's not 0 or 1. It's not, is the system broken? Is it working? They're statistical. So having someone who was involved in building that model be the person who runs operations for that is where I think we should go with ML ops. Would love to hear Kevin, your thoughts on this, Kevin and Barr.
Yeah, I'd love to add to that. So I definitely agree that DevOps and ML ops is not the same thing. In my mind, though, ML ops can learn a ton from DevOps, and it's the DevOps tooling, the DevOps platforms, and most importantly, the DevOps best practices that we need to bring over to ML ops. And maybe we can just recap those really quick. Like at the end of the day, the DevOps practices and tooling allows a software engineer to make a change to a line of code of a microservice that's currently running in production. I check this change into a Git branch. I get my pull request reviewed. And afterwards, once it's reviewed, there's automation happening behind the scenes, which is now going to build my container. It's going to test my container, and it's going to deploy my container to the production system. And I monitor in real time the health of the system. And what that allows folks to do is engineers are now really empowered. They own the system that's running in production. They're fully unblocked. There's automation in place that allows you to push a change to the production system within literally minutes. And with machine learning today, that's completely not the case. Like we all here know how long it takes to productionize machine learning. And we can take many, many pages out of the DevOps playbook to bring the exact same excellent experience and delightful experience that software developers have to data engineers and data scientists and ML engineers who are working together to productionize machine learning. And for me here, it's really about how do we make it as easy as possible if you change the script that's defining your training code, or if you change the code of your feature transformation to then automatically train a model and deploy it into production after you've tested it, and really safely roll it out to production so that you can squash this iteration loop and make it super quick for somebody to deploy an updated model, an updated feature to production.
Absolutely. I think what you hit on over there, which is like, what are the best practices that you can pull from the DevOps world into the ML ops world? I feel like there needs to be like a diagram that's like, okay, you check in your code in the DevOps world. Like, what does that mean? Is that registering your model in the machine learning world? If you're running CI/CD checks in the software world, is that proper automated model validation, like these one-to-one mappings between the DevOps world and the ML ops world. And I think that would make, the things you might be doing might be different, but the fundamental kind of steps might be the same.
Yep.
Feel the need, the urge to disagree with you all, but I'll just add to that. I think we've certainly seen sort of the DevOps practice emerge in the last sort of decade or so, or a couple of decades, and become prevalent. And I think we're seeing the same thing happen with ML ops now. To your sort of point around what are the best practices and methodology that we can adopt. If you think about sort of the core concept, or what is DevOps, or what's the goal of DevOps, right? It's to help build, the best sort of software applications or best software services that you can. And adopting that mindset, bringing that to machine learning is exactly what I think ML ops is about. And that means, delivering high quality products, those that are sort of secure and compliant and scalable, and allow us to have the fast feedback cycles and loops that we talked about. I think the main differences are, first and foremost, that there's very different stakeholders. So very different types of people with different backgrounds and different skill sets. And also obviously a very different stack, right? So different programming languages. And so there needs to be a significant adoption, or significant thoughtfulness and intention when we're making that adoption. But there's certainly a lot that we can learn. And I think we'll also see the emergence of sort of new roles as a result. Interestingly, like DevOps has brought on the role of SREs, right? Site reliability engineers. And I'm really curious to see what are the new roles that MLOps will bring in the next couple of years as well.
Yeah, but I feel like one trend that I've noticed, at least on LinkedIn and how people hire, is really ML engineers. I feel like there's a little bit of like championing for the person who actually takes that model and puts it in the real world. That's a hard job. It's almost like you got to know how the model's built, what it's trying to optimize for. And then you also got to know all of this software infrastructure to go make that successful in the real world. And I feel like when I remember when we were, we had ML engineers at Uber, and, that was kind of felt like a new role. It was like, maybe one of the first couple of companies to actually do it. And now you go look on LinkedIn, and like every fintech, has ML engineers. Every company that's sort of building towards an ML platform has an ML engineer. And I think this role is actually going to get really big. And I'm excited for that. I'm excited to see kind of what this role's, this person, are they responsible? Where does that line, that handoff go? Are they the persons who are actually doing the automated validation? Are they monitoring it in production? Like, what is this person's role and definition as we kind of go into this next era?
And how does it change too? Because I think ML engineers are extremely important and necessary today to get ML into production, specifically because there's so much tooling and so much of the platforms are missing today. So they have to do a lot of hands-on manual work to implement your, say, feature pipelines that turn your raw data into feature values, or that hand implement a productionized version of your model training script so that you now have a production-ready ML model. And they're the ones who then build a microservice that actually hosts the ML model and then puts it in production. There's a lot of stuff that actually can, to a large extent, be automated. Of course, not everything, but a lot of stuff can be automated to make things faster, safer, more secure, etc.
Yep, and not to forget once the model's in production, and then someone goes, "Hey, it doesn't look like it's working anymore," and then this person's got to go sift through Hive tables and figure out, why is my model not working? And that managing it once it's in, there's a journey of getting it into production. And then I would argue even a harder job of maintaining it in production. Because I think one of the differences, and maybe this is just my opinion, but I feel like code doesn't fundamentally degrade in production, right? There's bugs, but with models, there's kind of this concept of it degrades over time. And so you put something into production, the data, the world around you might change. And now, this person needs to make a decision of, when do I go update it? Is this still even relevant to the world that I live in today? And so that's one of, I feel like, a big difference between, I guess, the data ops, DevOps world and maybe the ML ops world is It's really the data going into the model could be changing, which in then impacts the model's response to that data.
Yeah, I agree with that. I think that is a big difference. Maybe the closest analog I can see in typical DevOps and software engineering is that you look at some health metrics like how is my memory consumption looking? Like how high is the load on my microservices? Maybe things are still changing in the world because there's now more load on the system. So I need to increase my provisioning. But you're right, there's many more additional failure modes with models around, are my feature distributions drifting? Do I need to retrain my model, or is there an upstream data outage that I need to fix and I'll backfill in order to get my model back into the green zone again?
Yep.
I would like to challenge what you're saying about the degradation issue. Maybe the code doesn't necessarily degrade, but the processes do, don't they? Barr?
Yeah, I'd say, well, I think the process may degrade and also the data itself, right? So to the point of the question, when does the ML engineer know whether to check whether the Hive tables, are up to date or not? Whether you're using the right tables, right? Whether you're relying on the right data set. So I think because the one constant thing in the data space is change, everyone's like adding more data sources. You mentioned fintech, and that's a great example of an industry where typical companies can rely on thousands of sources, oftentimes third-party data. And when you rely on that kind of data, changes are just part of your day-to-day. And in addition, you have sort of, many more people relying on this data. And with many more people relying on this data and using it, there could be changes all the time. And so, sort of assuming that the data that your machine learning model relies on is not a safe bet anymore. And because of that, you need to develop best practices and methodologies to make sure that you're doing what you can to deliver strong products. And that certainly can include sort of degradation and other sort of risks to your business for sure. I don't think there's a single person in data that has not encountered some horror stories. I heard there was a great panel about this yesterday. So I think we all have those, and I think solutions like Tecton and many others help us bring some best practices to making sure that we're staying on top of this as teams as an industry.
One of the questions that I have then is about that data itself. And it's almost reminded me of, of reading I've done and, some writing on the topic where it sometimes feels like data is like treated like, it's almost like the procession in a royal court. I mean, there are so many different ways to respect the data and treat the data and how you present it. And there's just so many different aspects to it because the data is not like code. It's really just everywhere. And so how do you think about that whole data operation in itself and how that fits with, the concepts of ML ops and that issue about degradation with the models themselves over time?
Yeah, so in my mind, and this brings me to a lot of people are often asking how do you even compare DevOps to data ops, and then how does it relate again to ML ops here? And the way I always think about that is that at the end of the day, your DevOps system, your DevOps pipeline, it is concerned with one type of artifact, and that's the service, that's the microservice or the container that at the end of the day gets created and put into production. If you look at the data ops world, it's not that simple anymore. Now you're suddenly dealing with two different classes of artifacts. You've got on the one side, the data pipeline artifact, which turns inputs into outputs. And then you've got the second category, the second class, which are the data assets themselves that are produced and consumed too. And you need to monitor and version and make it easy to develop both of these artifacts. How do I make it super easy to develop a new data pipeline? How do I make it super easy to monitor it? And how do I make it super easy to version and monitor even the data sets that are being generated by these pipelines? And then you bring, of course, ML ops into the whole story. Now it becomes even more complicated because now you're not just dealing with data pipelines and data assets, but now you're also dealing with model training code and you're dealing with the model assets themselves that you need to generate, version, control, monitor, and everything else.
I guess one way I think about this is kind of, there's kind of different needs for observability for all of these different categories. There's kind of the, what Barr's team's done an incredible job on, which is kind of data observability, which is working on top of looking at the data lineage, what, data freshness, schema changes. And then there's kind of ML observability, which also has things like model lineage. So it's like, there's like these parallel concepts of like model lineage. There's, in the ML world, you might want to do, cross model, cross feature analysis, looking at training versus production for a feature. And so it almost feels like, the requirements for what you need to kind of safely automate away a lot of these processes is really good kind of observability, and the needs for them are different across DevOps, data ops, and ML ops.
Barr, so observability is back at center stage in some respects, isn't it?
Yeah, it's the new hot topic, observability for sure. And again, like all credit goes to DevOps, right? So we didn't make this up. And this is like tried, proven in DevOps, and we now need to implement this in new areas. I think that, there was, just for folks sort of not familiar, kind of with the concepts of observability, observability is basically sort of the ability to observe the health of a system based on its outputs. And so the idea is that, things can break in distributed environments, and obviously there's lots of change introduced in complex environments. And one way to measure the health of that system is by observing it. And so in DevOps, it's very well understood what you actually need to observe, right? And observability typically includes things like both monitoring, but also troubleshooting, tracing, et cetera. And so what do you actually monitor an instrument for is pretty clear in DevOps, right? There's things like performance and latency and CPU and, all these like best practices and best in class tools that we have for observability. And when it comes to data observability, to ML observability, those are all new territories for us. And so it's, up to us to define what is best in class observability, and also make it easier for all of us to be able to actually build data products with observability from day one. Oftentimes we see, folks who want to get started and all the sort of good stuff and exciting sort of advances, but end up sort of struggling with some of the fundamentals around like, where did this data even come from, and can I even use it? How old is this data? And so getting those best practices in place is, I think, something that's just fundamental for anyone kind of in ML, data engineering.
Curious how you think.
Go ahead.
Aparna, I'll let you go.
Okay, I guess I'll go. I guess the one point, because Barr and I kind of both work in the observability space. I think one of the things our teams have actually talked about is, and plug, we're kind of writing a new piece together, so I'm excited for that. It's kind of observability in the data space versus observability in the ML space. But one of the things that I think both of us kind of agree on is, what is the difference between monitoring and observability? And we kind of fundamentally see, observability is kind of really the whole health of the system, being able to not only pinpoint like red light, green light, something's gone down, but why? Like, why did it go down? And tell me how to go fix it. Like, that's the hard part. And there's some really good practices from DevOps that I think these new spaces are actually learning from and trying to pull from, so that we can try to create those flows that DevOps have to fixing and remediating the problem. And we can do that in the ML and data categories too.
One thing that I'd be curious to get your opinion on is, when I look at what do I wish the future looks like when it comes to data processing, model predictions, model developing, et cetera, is that at some point we're going to have a world where an organization can just look at one gigantic DAG in their organization that defines what are all my data inputs, what are all my feature transformations, what are all my otherwise data transformations, what are all my ML models, what are all the predictions they generate. And you've got this gigantic web basically that shows you exactly what's going on anywhere in the organization of any system that touches anything with data. And you just see red and green and yellow, and then you can zoom in and maybe retry some things, but you get the central aggregated view of what's going on with my data and ML health in the system. And I'm curious how you view that, and to what extent do you think observability is going to become consolidated or aggregated, where companies and the individual stakeholders are going to have a unified view somewhere where they do see everything around observability and what's going on, actually from software and DevOps to data ops to ML ops, and how you fast forward that and what your vision there is.
Yeah, I mean, if there's one thing that we can all agree on is I just can't imagine a world where that isn't a part of the story, right? Like, and isn't like a huge part of the story. It's mind blowing to me that we don't even have that today, right? If you think about, any engineering organization, sort of working without DevOps or without observability or kind of without this like holistic view, it kind of seems like a joke to us, right? Or sort of laughing. But for some reason we've gotten away with like not doing that in data, like God help us, right? I don't actually know how we've been like survived to date. But when I think about, 5 to 10 years from now, it's clear to me that the future that you're describing is just inevitable, right? Especially since literally every company is becoming a data company. I know sounds like a cliche, and I think we've said it for decades, but I can think that we can more genuinely the numbers and the data actually back us to say that today, that more and more more and more organizations are turning to data as a competitive advantage. And we see that with sort of, more and more folks in ML engineering roles, and, obviously sort of the market, the data market, how it's evolved in the last, honestly, 12 to 18 months has been sort of just, palpable speed. And so I just can't envision a world where this doesn't exist. Now, to the point of like, how do we get there? What does that look like? I think there's lots of challenges to figure out on that path, right? So I'll start even with sort of the easiest one. When you think about that sort of like centralized view, it looks very different in the world of like, an ML engineer, a data engineer, a data scientist, a data analyst, and a software engineer, right? They might have very different interactions with data. They might have very different interaction with that overall view. And so, I think some of the sort of burden of proof on us and some of the challenges that we face is, how do we make these interfaces something that people can interact with and use with? How do we make the communication between these groups work? Those are all challenges that we are not close to figuring it out. And I'm really excited to see what we come up with. But I feel very, very confident that that's where we're heading, and the faster we can figure it out, the better.
I think, Barr, that's exactly the point I was going to make, is that flow that Kevin described, there's different people across that flow. Like the person who actually looks at all of my tables is going to be different than the person who looks at all of my models. And then the individual person who might care about a specific model and how that specific model is performing. Like there might be different stakeholders across, or engineers that are across that flow. I guess the way there's a lot of concepts, a lot of words. MLOps is growing at like this incredibly fast pace. I feel like the way that I kind of, segment the world, so I can at least try to box it. And like, these are the 3 core areas that I think we're going to see a lot of movement in, at least on the ML infrastructure side, is, first, there's, getting from all of your data down to, I think what your team's doing over at Tecton, which is really the feature store, that central spot where all of the inputs for your models are coming from, is the central repository for how you handle different transformations. And then there's kind of the model store, which is the registry for models, tracks, things like what's your latest version, which models are actually deployed in production. And then I think, Josh Tobin actually meant this word, but, I love this word. It's kind of the evaluation store, which is really down to capturing the individual predictions and managing things like, the actual, drift, data quality, performance of each individual model. And so I think broadly segmenting into the feature store, the model store, the evaluation store kind of helps me at least kind of see that flow down of, what should each parts of those platform do. Feature store handles certain aspects, model store does different, evaluation store does different, and there's different users of all 3 of those platforms.
So when you think of all that, and then you think about differential management of the models themselves, and it goes back to that topic of decay, how are you seeing it visualized? How are you seeing that, those three boxes essentially kind of viewed, and being able to like represented so they could be standardized and used by, people to scale out their models themselves without them degrading.
For me,
Yeah.
I can take this one. So there's kind of, that's a great question. And so I think that the interfaces between those three platforms that I described is something that I feel like the industry is still kind of getting the protocols on. How should the feature store integrate with the model store? Should the model store say, link back to the feature store and say these features are used in these models and there's an overlap, if you have a model deployed in every single state or city, for instance, should there be some connection to the feature store and the model store that shows all of those groups of features that are used in the models? And then between the model store and the evaluation store, there's this exchange between what's my latest model? How do I store all of the different evaluation metrics across different versions, different environments? Like there's an interface that needs to be figured out between those two. And then I feel like there's an interface between the evaluation store and the feature store, which is kind of as features start to degrade in production or you start to notice data quality issues, do you do things like, pull the most latest refresh of, do you go trigger a retrain on your model? Do you go and decide to use your offline features? Do you decide to at least, call out that there's bugs in your feature transformation layer? Like there's these feedback loops and interfaces that need to occur between all three of these platforms for, I think, machine learning to really be this truly automated vision that Kevin was kind of highlighting, where click button, things deploy, things work great. When things have a problem, automatically go fix yourself, and then go fix yourself and kind of auto learn where you need to go improve. Like that's the vision that I have for the future. And these systems need to work together. And I think the defining the interfaces between the platforms is probably where I feel the biggest conversation is going to happen in the next year or so.
Yeah, I agree that it's super important to nail those interfaces so that the different systems really neatly integrate with each other, because at the end of the day, this would then also allow companies to purchase best-in-class tools for the different components of this workflow. And then they know, given that they're all hopefully implementing very similar identical interfaces, that you can package it all up together. And now you've got one nicely integrated platform. And then ideally there's this additional interface to the end user, who then doesn't even have to necessarily know anymore, hey, there's like 5 different systems, 5 different platforms under the hood, because it's so neatly integrated with each other, where it just feels like an end-to-end platform that solves my entire problem end-to-end, even though under the hood, it's different best-in-class tools and platforms that the company was able to purchase and then stitch together.
So go ahead.
Go ahead. I just wanted to mention one, paper, recent work that Andrew Ng released a few months ago that I thought was really interesting in terms of some research that he did around, when there's a problem with a model, there's, to Aparna's point, there's a lot of different things that could go wrong, and where do you actually sort of start and how do you troubleshoot? And in some ideal world, there's also some, self troubleshooting and, self-healing way to do that. Until we get there, where do you actually start? And some of his results actually speak to whether, the issue is in the model itself or in the data itself, and sort of advocates for thinking about being data-centric and model-centric. And I think that's, pretty controversial, definitely not something that's sort of well accepted in the industry today. And I just thought that it was a really interesting take, and perhaps, one of the very first discussions on this in a data-driven way. So actually being able to prove, how does a model improve based on the data-centric versus the model-centric way is quite interesting. So I thought that was, a new take on this problem.
Yeah, no, I think that's a really good point, because it's like garbage in, garbage out. So much of this depends on, are you getting good data to even go into your models? And maybe I'd even add one more, which is like just tying back into the DevOps world. Some parts of it could be just, service health, kind of like there's like the model, which is core algorithm, and then data-centric metrics, which is kind of the data, data quality issues, drift, you could even say is perhaps, could come back to a data quality issue. And then there's really kind of service health metrics. What if the microservice that was serving your model goes down? Like that's another, or doesn't scale up. Like that's might be even a whole nother category of failure modes for a model.
We have one question we should ask it just before we finish up. Should there not be a way for new improved model to supersede the older model in identical interfaces? Who'd like to take a crack at that? Barr?
I'll let Aparna, did you want to go? Go ahead.
Oh no, I feel like my answer is obvious. Yes. Like I think that in an ideal world where these systems are automated, if you have a better version of your model, or you know, we used to have some of these systems in some of the older teams that I worked on. It's kind of like a rollback. You could roll back to older versions of your models that you knew performed well if your performance got to a certain, started to degrade. But if you do, have a new version of the model and you're trying to, you've properly A/B tested it, you know that this one's better, and you run it on Shadow, when it starts to perform better than your existing model, it should supersede and start to take over. I guess, there's a lot of steps, I guess, in getting to that journey, starting from, what Barr was heading out, which is you need to have really good data observability to even know that the data is in a good spot. You need to have really good feature transformations. It kind of, you want that whole system lined up in place. And of course, observability in the ML context to be able to automatically, trigger actions if you know what it's going to do. But it's a journey and we're going to get there. But I'm excited for kind of the all of these systems to kind of work together and get to a spot where we can automate these.
Yeah, I think that's right. And I think that's sort of one sort of tactic and kind of a toolbox that teams need to have in order to kind of, have these best practices in place. And for each team and organization, there might be different tactics that you deploy earlier versus later. It's helpful to think a little bit about like where you are in sort of maturity curve in terms of ML in production and what's your path to getting there. Tools is certainly one part of the solution, but it's probably not the only one. Like thinking about who are the different people involved, how the organization work together, getting support for that. And maybe most importantly, like making sure that there's value to the work that you're doing, that people are actually benefiting from it. So whether it's sort of internal consumers or external customers, making sure that you're making a real impact with your work is probably sort of the best way, I think, for us to get a hold on all of these.
Kevin, why don't you take it out? I think we're coming up to our end of our time. I believe that we're coming pretty close. So, Kevin, why don't you help us finish this up?
Sure. I mean, I'd love to just go back to this question really quick that was posed, and I'd say in DevOps, you've got Canary Deployments, which we can learn from, which is a page out of the playbook we can definitely bring over here, where you put something. You develop a new service, you put it partially into production, you throw some shadow traffic at it, you monitor the health of it, and then you roll it out or you roll it back. That's the exact same thing that we need with models, where you have a new challenger model, you put it out there, you put some shadow traffic against it, maybe even some real traffic against it, you see how the model performs, and then you execute the full rollout or you roll it back. And so that's exactly the type of tooling that we need in order to make it easier for folks to develop new models, better models, try out things without having to be scared about putting potentially a worse version of a model out into production.
Well, excellent. I want to thank everyone for their time. I know, Barr, are you speaking later today as well on data observability?
Actually spoke about it yesterday, so you can watch the recording.
Okay.
It was right after the meditation, which was a great session too.
Oh, really? Gosh, well, I missed that, unfortunately. Awesome. Well, thank you, everyone. This has been really, I guess, illuminating for me. I'm learning a lot about how MLOps really does, play a role for this new generation of ML engineers and people in this space. So thank you all for your time.
Absolutely. Thanks for being a great host.
Thanks
Thank you
so much, Alex, Kevin, Barr.